This question is asking us to draw the remaining 5 Newman projections for butane as we rotate it around in a circle. To do so, I'm going to hold the back carbon constant and only rotate around the front carbon as I draw the remaining Newman projections. The first Newman projection will have a dihedral angle of 60 degrees, so if we start with our circle and dot for the Newman projection, I'm going to leave the back carbon constant, and I'll rotate the front carbon 60 degrees. Then we'll put the CH3 group gauche to the original CH3 group, and the 2 hydrogens offset like this. The next Newman projection will be the 120-degree Newman projection. So again, starting with our dot and our circle, I'll leave the back carbon constant. Rotating another 60 degrees is going to bring the CH3 group eclipsed with this hydrogen. And we'll make the other hydrogens eclipsed as well. This will be the 120-degree dihedral angle. Next will be the 180-degree dihedral angle. Again, we'll start with our dot and our circle. I'll keep the back carbon constant. 180-degree dihedral angle would put the other CH3 group down at the vertical position in the southern hemisphere, and the remaining 2 hydrogens in the northern position, northern hemisphere gauche. 240-degree dihedral angle, we'll start with our dot and our circle. We'll continue rotating the CH3 group around. We'll keep the back carbon constant again. 240-degree dihedral angle will bring the CH3 group eclipsed with this hydrogen, and the other hydrogens will be eclipsed as well. And finally, the 300-degree dihedral angle will have the CH3 group gauche with our original CH3 group. We'll keep the back carbon constant. This carbon will be gauche, and the 2 hydrogens will be drawn in accordingly. These are the remaining 5 Newman projections for the conformations of butane.